previously on the Rust course. Q television segu. In order to understand what we're about to look into, which is ownership in Rust, you should now have a fairly clear differential view between the stack versus the heap, right? And recall, we have these primitives in the stack, and then maybe we have specific vectors or whatever it is set up in the heap, okay? And the stack is a sufficient mode for memory allocation, whereas the heap takes more complexity but has an unlimited size. Given that, let's take a look at this idea of ownership in Rust. So what do we mean by that when we talk about ownership? Well, variables of a value, all right, any variables of a certain value have an owner in Rust. All right, that means that all the data, that is stored in Rust would have an owner associated with that data. So what do I mean by that? Well, let's say we have time. You have a variable time, and that time is 20. So the value is 20, and its owner is time, right? Now, hopefully you already have that idea down when we looked at variables, but now we're looking at it in terms of ownership of data, not practicality of coding. So what are the rules? Well, data can only have one owner at a time. That means that multiple variables cannot point to the same memory location. Rust is all about efficient memory, avoiding memory leakage issues. So this is an important rule. Variables always point to different memory locations. They're not going to point to the same memory location. Now, that being said, can you transfer ownership? Well, absolutely. And we've done it before. You can assign one variable's value to another variable, right? Also inputting value to a function, outputting value from a function. All right, this is the transfership of ownership, which is possible. Now let's take a look let's take a look more concretely, a little bit more deeply, with an example. And for this example, I'm going to use a vector. Well, I don't know if we've covered vectors, so I got a little bit here about a vector. So vector is basically a data structure. It's going to contain 0 or more items of the same type. All right. And the items are going to have an order, and you can access the items by index. All right. Similar to an array to some extent. Now, you can add and remove items, and the items themselves are stored in a contiguous heap allocated area. All right, so what we're going to do is we're not going to look with primitives like we've been doing before. We're going to actually see what happens with the Rust compiler when we point with heap allocated space. All right, so let's write that out together, and hopefully it'll become more clear. So we're going to have a function, main, our favorite that we always bring in here, right? Okay, let's make it a little bit larger. All right, so I'm going to set up a vector. So I'm going to say let vector1, and there is a vec macro that can then allocate to the heap. All right, so we're going to do vec and then the macro sign, which you should be familiar with. And we want to create this vector sort of like an array, so we're going to bring in the brackets and then pass in some values of the same type. So that could be 2, 4, and 6. Okay. Now, and by the way, just a comment, the vector, so the vector v1 owns, it's going to own object, okay, in the heap. All right, owns the object in the heap. And remember that only a single variable, oops, it's not how you spell single, only a single variable owns the heap memory at a given time, right? To avoid any type of data confliction. So vector1 now owns that, right? So given these rules, let's see what happens if we create another vector, vector2, and we set vector2 to vector1. I don't know why I'm not spelling today. Let vector2 equal vector1. So what's going to happen here? Well, Rust is going to check for memory access. And that's really a key selling point. It's a key selling point for Rust. It really is. It really is. So let's actually see this in action. So if I were to print, oops, What is that? Okay, it's bringing in emojis. Let's say I were to print here. And remember, because we got multiple types here, we bring in our colon and question mark. Let's say we were to print here vector2. Would this work or not? Would this work or not? Pause the video and consider. Will this code run? All right, do you have an answer? Well, let's run and find out. So I'm going to hit run. Hopefully I made no mistakes in the code. And look, there you go. Look, it is working. So if you guessed it's working, then good job. 2, 4, 6. The memory heap allocation is now changed from vector1 to vector2. Vector2 is now occupying the space. Rust automatically checks, sees that it's changed. There's no problem with that. But what happens if I switch to vector1? What happens if I switch to vector1? Let's rerun again with the compilation. Whoa, 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 we've got some errors here. What's going on? So we see borrow of moved value error, E382, okay? So the borrow of moved value is basically Rust saying, wait a minute, the heap allocation has changed, so vector1 is no longer occupying that space. All right, now this belongs to vector2. All right, so you can't run vector1. It's not going to let you. And in a nutshell, that's how ownership works in Rust. So it's conceptual. I know we're not really coding. I know I'm not giving you any exercise to code, but you need to understand these concepts as we move deeper. I want to make sure that you have at least clear basic knowledge of what we're talking about. So if you're a little confused, take your time with this, go through it, and we can stop there. We're going to continue on with this idea of borrowing in the next lesson. All right, so we'll stop there, and then let's keep getting deeper. Deeper and deeper down the Rust rabbit hole we go. Okay, I'll see you when you're ready. Bye-bye.